Okay. So, so what did we do up to now? Just to recall, so the idea was to build a Docker image. We have spent most of the time configuring my environment, part of that, but we kind of got there. So now we learn about Snap. We downloaded the individual packages. We ran go get. We cleaned up some of the issues in those packages. For example, the fact that there was another executable talk compiled into it.
And talk?
Sorry?
What is a talk?
A talk. Mariusz used that StudentDB repository to store some course-related files. So some other non-code related files. So and those don't compile. And since they're not necessary, I forked the entire repository, which was a bit ad hoc, and then cloned that, deleted those talks, and then committed and pushed to my own repository. So he still has it. I don't know what his plans are. So we're working on that one. So basically, I just modified the repository, pushed the latest version, and then the idea was to test that it runs locally, which we kind of did, right? So go get, go install, running the executable. We exported the ports, which is environment variable, provided by Heroku as well, right? The ports that you need for execution. And now we're down to the Docker file. So that's the beauty of cloud environments, yet another cloud environment here. But I think I kind of got it reconstructed now. And now we're finally at the stage that we're saying, okay, let's do everything from Docker itself, right? We tested first that it works. And again, if you do that with your own stuff and you works in your own assignments, download them first and show that they work properly before continuing with this one. Because I can't repeat it often enough. It's actually fairly hard to debug errors from within Docker. It's possible, but it's tedious. It's not really super convenient. It's really made for automating something that hopefully works at this stage already. So that's the key idea. So because at this level, we want to work with plugging problems such as, oh, you got the ports wrong, or you got an identifier wrong, but not so much that you have syntactic errors in your code. So that's not something you want to deal with, or semantic errors ideally anyway. But so it's really about plugging everything together into multiple individual microservices that I can then communicate. But we are not at this stage. We're building the first one right now, our little first Docker file. So the idea is we have a from image. We are using Docker, Golang 1.9.2. We have a maintainer, someone. We running apt-get update and upgrade. You can always do that as default pretty much, as long as you run a Linux image. And then we actually get the clean repository now. So that's a URL, go get, and we do go install with the full path. And then from the working directory of go path, we execute /bin studentdb, right? Which is the executable. Makes sense so far? Who's lost? Is anyone lost? Shouldn't be, right? And then the idea is basically to build it. So right now, if you look at Docker, I just clean it up a bit. There shouldn't be any. Man, was I wrong. There shouldn't be any images, was what I wanted to say. So let's see if we can delete them in one go. Docker images -q. Let's see if that works here as well. Oh yeah, cool, it works. So not sure if that's super clever, but I deleted pretty much everything right now. So what I did here, just to give you an insight of what's happened. So you know that Docker has a very set of help commands, right? So, and I just wanted to delete all the instance, everything that's there on Docker, so we have a clean new installation. The two important commands I'm pointing to here right now are rm and rmi. Rm stands for deleting individual containers, so the instances, whereas rmi stands for deleting images, right? So the images containers are spawned off. So if we now run sudo docker ps, for example, we don't see any containers. If you run ps-a, it means show me all containers, irrespective whether they're running or not. And no, we don't have any remaining ones. If we do this, if we look at images, we will always get all images because there is no non-running or running images or whatever else, right? So there's a few images left that haven't been deleted, but that's fine. We can just live with this. What I ran before, just to give you some indication, if you want to quickly delete heaps of your containers, which will eventually happen in the future, and we'll probably try that later on, you can run something like rm docker rmi, and then hang on, I need to find the right. Yep. And then we open a subshell, basically basically precede the execution of that general command with a specific command and use the return value as input for that command here. So what you can do is basically tell Docker, give me all images, sudo docker images, and give me those in the short form, -q. It will only give the IDs, unique IDs. And those IDs can then be used in RMI to simply delete the images. Yeah, injected, please.
Wouldn't a pipe do the same thing?
You can do the same thing with piping, yes. Yeah. So
you just mix the order?
Yes, you will change the order, say sudo docker get images pipe, and then sudo RMI, docker RMI, and then it should be fine, yeah. But this is the recommended way here for Docker specific. You could, yeah, so then that's the default way. I would suggest using that one. But it's up to you, obviously, multiple ways. This is more like, yeah, conventional best practice right now anyway. Right, let's build a file. So we want to build something. We need to say sudo docker build. We need to have a tag that we want to give it. Let's call that, we don't need to, otherwise you have a unique identifier that looks like this, meaning it's hardly useful. Instead, let's call it studentdb, yeah, studentdb, why not? Doesn't hurt. And we can give it a some sort of version tag 01, for example. And we need to specify the build context, meaning telling the system, Docker, in which folder to look into when performing the actual build. In this case, we don't have any external, well, external local dependencies, meaning nothing on the file system, but only URLs, which is quite straightforward. So we can just have a directory with only containing the Docker file itself. So it will automatically look for a Docker file and execute it and perform those tasks. So what it will do first, we'll be downloading the image for Golang 1 and 2. We did this earlier already, so so meaning it's still cached, so it's relatively fast. Then it creates the next layer that introduces the maintainer, the next layer that does the upget update, which is still running, upgrade, update, and upgrade. And down here, all right, now it's actually running the fourth step. So the fourth layer, go get, and then get the corresponding code. Then do the go install, and again having a layer, yet another layer in the container, and then changing to the working directory before finally setting up, specifying the entry point. So that's the default command that's run when this container started. And then it tells you, okay, successfully built the container, gives you a unique ID. That's the unique identifier the container will be accessible under. Note that all those intermediary containers, those layers, are actually deleted upon successful compilation of the image. And then it's tagged to studentdb1. I can just recommend you to do this tagging from the get-go, because it's a lot easier to write out your tag if you want to delete or modify a container than the full ID. Especially since, at least as far as I've seen, there's no tab-based code completion in the command line for that. Anyway, all right, if we run now those sudo docker images, we should see our image in addition to the base images, which are kind of handy to have. So there's studentdb1, and we want to run it. So yes, so sudo docker run. So one of the aspects is to run it as -d. -d means detached, meaning return the command line after execution or after invoking that command, so I can continue using my command line. Otherwise, it will produce any bind it to that particular console. Cool. So we want to give a name for the particular container, which we call studentdb01, for example. Then what else do we need to do? What other things do the executables rely on? Remember Heroku style? Environmental variables, right? So we need to do that as well. And we do that with -e. And that would be port 8080. If you have multiple of those, you have multiple -e statements. You have something like that, right? So if you had a db equals whatever, so that's the way if you had multiple. But right now we are self-contained. It's an in-memory database, so we don't have any of that to deal with. Cool, we have the name.
It sets an environment variable.
It injects the environment variable into the Docker container. Yeah. Yeah. What was the other thing we need to deal with? How do we link it to the real world? Ports, right?
Address.
Yeah. So internally, well, since we kind of, we can specify it ourselves. So internally, we specified port 8080, so we know the application will be listened on port 8080, which will be this one here, the second one. Oh, sorry. But if you wanted to change the outside port, for example, we could use an arbitrary port number here, right? Like 80 or something like that. So that's host, that's container. Cool. And then we need to specify the image we need to build from or want to build from, which is student db 0.1. All right. Oh, that actually worked. Good. Sudo docker ps. Right. So PS shows you running Docker processes or containers. If you want to see all of them, but it's of little value right now that you just say -a, that also shows the ones that are not running, right? So right now we have an instance of the image studentdb01. It's currently running the command /bin studentdb, so it has seemingly successfully invoked our service. It's up for created 13 seconds ago and has been launched 12 seconds ago. The port mapping is as follows. The host ports, so 0000, what does that mean?
Everything.
Everything, right? I mean, any host interface on the host machine is has the port 8080. Its port 8080 is bound to the Docker instance's port 8080, right? So if you have 5 different interfaces, any request to port 8080 and whatever IP address it has would redirect to the Docker container. Please.
So inside the container, you only deal with the ports, not the addresses.
You can. Docker also has a nested network concept, which you can use. I'll probably get closer to that later, but there's, in fact, by default it does so. There's 3 ways in which you can set up a Docker network by default. So you have the this is the host. Those are containers C1, C2. Right? So by default, they can be connected via a bridge called Docker 0. So it's the default initialization. And in this case, they can theoretically communicate with each other, but not really to the outside world. So they can communicate to the outside world, but no outside world entity can access them. The second one would be to directly attach a Docker container to a host, binding to a host port. In this case, the Docker container would not communicate inside this internal Docker network, but rather be accessible, to the world directly. On the third variant is simply not to have any connectivity, right? Docker container without network connectivity. When is that useful? Is that useful? Anyone?
If you communicate via files instead.
Exactly. Right? So if, for example, you're delegating some number crunching activity to a Docker instance, or 50 or 5 million of them, then you may not actually need network communication, but just work based on files, right? That you inject perhaps at runtime or compile time, right? So those are 3 variants of communication. What we said right now, well, we actually want to bind the port 8080 on that machine here to the host port 8080. So any request coming in here to the host will be redirected to that particular container. That's what this command is about. Yeah? If you don't do this, you will only have communication amongst containers, right? Which is fine, but you won't be accessible from the outside world. But we need this in order to invoke the containers, from the network and then also expose it. So that's what the port statement is for here, down here. Last but not least, here's then the name. So it's a bit because of the layout here, the name of the actual instance, right? So it's studentdb01 right now. Cool. So let's just test that it actually works. That's one of the challenging things, that sometimes you need to actually test that properly. Are we on the same machine? That looks good. Cool. Oops. Actually was probably a different machine. Anyway, so we have a 200, nothing in there. If we do a post, we should then be able to store something in the in-memory database. That's the 200, and we do a get, yes, and we get check out of it, right? Recall that those two files are just dummy requests with valid JSON for the post request, and get just to test it. Emulated via curl, so you can do that as well for your environments. Good, so this is the basic running variant of the Dockerized version of the application. Obviously, that's not 100% of what you probably need to do. There's some other aspects to be considered. So I just bring the Docker file up again. So it's relatively straightforward to actually do it. Any ideas about potential shortcomings? Yep, please, Jonas.
So on the network again,
yep.
When you in one Docker image specify that you want to get something from localhost 8080,
yeah,
which is in another Docker image.
Mm-hmm.
So it would be, that would work. You have access to every Docker image through the host.
You could do that, but the preferred way, but the question is, sometimes you have the case that you actually don't really want to, yes, the short answer is yes, you can do it. The long answer is you need to think carefully when you actually do it. So if you have a the host network, it may sometimes be enough to have direct communication with the other container, right? So instead of going via the host, both for performance, but also, yep.
Because now you have both the web service and the database inside the same image.
Right now, frankly, they are in the same container. Remember, it's the in-memory. So we're not even down to that level that we have multiple containers. So now it's super self-contained, no fuss. But let's think about having the MongoDB instance elsewhere, right? So that's what you want to get at.
Yeah.
So in this case, we probably should do that actually as a next step. The idea is there. How do those two containers communicate? The question is ultimately, is it useful to expose all services to the internet? That's the question to ask. In the case of our system, is that useful? Not? Yes, perhaps. No. Which service shouldn't be on the internet?
Database.
The database, right? So you can actually leverage benefits here by not going via the host for security reasons, because in fact, in this case, you actually don't even need to have proper authentication issue. I mean, that's boils down to your paranoia in the end. But as long as you're only in the Docker network that's running on that particular host, it's host specific, then you actually have direct access to the other container. And you address them interestingly by name, by container name. Yeah? When you give them names, like for example app here, and this is db here, you should be able to address this machine just by its name as a URL. What happens here in the network is that there's actually a, during instantiation, the Docker containers are injected basically the reference of those names, of those host names, to the corresponding IP addresses, like a DNS service, right? So where you have name and pointer to IP addresses. So that answers a bit of your first question that you had a few minutes earlier, which are there IP addresses here and how does it work? Yes, there are IP addresses here, but you should never need to deal with them because they change, right? So if you bring down a container, you get assigned a new IP address afterwards, and there would be a lot of internal fussing around figuring this out, which is possible, but should be unnecessary. We work on the layer above it. So ideally, if you work in this Docker bridge, as it's called, you should be able to address them purely based on their names. So if you assign meaningful names doing instantiation, you can solve that issue out of the box. So you encode it. Yep.
And port also. You specify the port?
Yes, you will. You need to specify. Well, it depends on the short answer is yes, you need to specify the port, but it depends on the service. For example, if you use a tool that, for example, Mongo client by default looks, if you don't specify a port, looks at the default port, which is 27017 or something like this. So in this case, you don't explicitly specify a port, but yes, to access the service on another console container, either your client or yourself need to specify a port. Yes, that's right. Yeah. So they are really treated as individual entities, but still have the same necessity of specifying the port. You just don't explicitly deal with IP addresses, but you could. If you want to. I mean, there's a lot of work on Docker networking, which is a bit, a bit involved. I don't think we want to go down that route right now, but it's probably worthwhile thinking about this. Okay, but let's follow that path and look if we can integrate MongoDB. So we probably need to rewrite the code a bit. All right, let's see what we have. It's in Go. Hang on. Wait, we have the Go get. I need to download my stuff. I have to change the instance yet again. Come on. So let's explore what we need to do. GitHub, so IMT, CMD. Where do we change the configuration? I think we did it here. Let's do it in nano main.go. So what I'm looking for now is to get away from the in-memory database, which is convenient and easy, to the use of a the Mongo one. Right. So let's try that. So we comment this one, we uncomment this one, and okay, we're using MongoDB here. Right. So we can should be able to substitute this one without much fuss. See how far we get. So instead of okay, let's make up a environment variable. How do we call it? Anyone? Good. So get n db host will do, I guess. That should work. I'll also add a that's where sanity comes in. I'll also add a debug statement to make that a bit more visible. Let's see. Really? db host. Cool. Right. See how far we get with that. Could work. I got something wrong as expected, so let's see. Go in. Forgot a bracket here. Cool, that looks better. So we modified this one. All right, so let's think about how do we go about it. First of all, we need to get a database. So standard approach. Let's find a good database solution. Let's see. For whatever reason, that is always in the foreground here. So. Here's the Mongo database, the default one. So a reasonable one seems to be 3.410, Jesse. That's the latest stable. So it's probably something we could work off. Yep. So to do that, let's go back here. Note that you have the same functionality in using Docker search. So sudo docker search Mongo. We'll actually connect to Docker Hub and figure out the images, and you find that the the official one is generally found on top again anyway. So we say sudo docker pull Mongo. Let's see if we get the specific tag. Cool. So you don't need to explicitly pull the file. You can also just do it via the Docker file itself. It will do it once requested, but in this case, I'm just doing explicitly in advance, mostly to test that it actually exists. Right, cool. So, yeah, before I forget that, forgot to commit. Let's commit this. Get to see what we change. Stupid me. Hang on. Should have done the modifications outside. So what I'm doing now is downloading the repository again, because again it's a different instance than the one before for whatever configuration reasons. And then do the modifications I just did here again. It should be relatively straightforward. Go cmd student db go nano main and that was basically os get env lowercase, else that's probably not working, and then db host, which is the variable name of choice, comma, print 9, db host os dot get env. So, this time without bracketing problems. Okay. Status. And switched to MongoDB.
Did you run it?
Not yet. Not yet. That's a good point. But we don't have a don't have a local Mongo instance right now, right? So, okay.
So it's just fingers crossed.
Yeah, somewhat.
difference between the Mongo server and the Mongo clients?
Client is only for accessing MongoDB servers, but doesn't necessarily mean that you run one locally. Whereas the server is the server running on your machine, but you don't necessarily need, well, you kind of need to have a client, but you technically wouldn't need to have a client to access it, right? You're just running, providing the service. Doesn't imply that you need to access it from that very same machine.
Snap only has the server, so I have to install the server from Snap and then the clients from the app.
Okay. Okay.
I would wonder if that would work. If they're interoperable.
Sudo. So I'm creating the data.db folder. So we see that the Mongo service is actually running. Sudo system ctl MongoDB status. Let's see what's running. EverSign. Unknown operation doesn't find the service. Let's see Mongo. MongoDB server, MongoDB server.
What does the system CTL command mean?
It's just checking system services. So it will tell you whether a service Mongo is registered or not. That's the purpose of it. There's something. There's something. Okay. So yeah, but okay. So what it says here is that the MongoDB service, well, and then some description, it happens to be this one here, is actually active and running. So it's your way of figuring it out. Sudo service MongoDB, that's the service name, on the system, and status, just give you a status. You can run it also with stop and start or restart, and that would basically do precisely what it suggests. It restarts or stops the service. So it seems to be running, so we can obviously, or we should test that. Oops, yeah, we actually can interact with it, right? Cool. All right, we have a local service. So it implies for our little student DB that we have just built. Did we actually go get install? CD source, CD GitHub.com, rm-r. Sudo. Good. And then let's say go get GitHub. We want cloud. Good. Works for me. All right, cool. So, as good citizens, we will test it, obviously. So, we have downloaded MongoDB. Now we need to configure it somewhat. The only thing we haven't configured is the environment variable. I called it DB host, so we need to give it some meaningful URL.
Question?
Yeah, please.
You injected the environment variables into the Docker image earlier. Wouldn't it also? Why didn't you just hardcode it in the, or could you hardcode it in the Docker file?
Yeah. So two things right now. Just to clarify, right now I'm not doing Docker, right? So I'm just doing offline testing. What you suggested. So you could, yes, you could hardcode them.
Just export.
That's right. That's right. You can do that in Docker as well if you wanted to. But you generally, again, we want to have the same mechanism of separating implementation from configuration in a way. So, and this is basically the linking pins, which is database and ports, which links it to the outside world. And that's the kind of thing you kind of want to explicitly control during instantiation. That said, in Docker, when you write Docker files, there's an expose instruction, right? You came across that, I assume. When you write Docker files, you write something like expose 8080. This is mostly descriptive, though. It just says, well, this container exposes something on port 8080, but it doesn't enforce anything in particular. It's more like has a documentary value. You still need to do an explicit indication. How does my host that runs Docker, the Docker environment, relate to that or link to that container? Yeah. Perhaps you really don't want it. You can. You could obviously hardcode port 8080 in the container, but you may link it to a different port on the particular host. What I'm doing here is to minimize the change on the code base, so it still hopefully runs on Heroku. But yes, you're right. You can do all the same in the entire container if you like. Yes. So just double check if my variables are properly specified. And then we'll see. Go. That wasn't too persistent. Let's see if Mongo is actually bound to a port. Status A. 2701, yep, that looks pretty good. But yeah. Too much navigation. So cat so port is specified. Get env global init. Did it get its own port? To check that because it didn't bind, didn't block here and listen and serve. So that's weird. Perhaps there's some, it may be something else running. Sudo docker ts. Yeah, there's something else running on port 8080. That may be the reason. Sudo docker stop student db01. So this is the Docker command for stopping a particular container here with the name down here. Don't confuse it with the image. That's different. So you need to indicate the instance name, in this case container name, if you want to stop it. Something that can be somewhat annoying if you specify multiple Docker containers, it seemingly still binds port 8080. So if you run another Docker instance or container instance also with port 8080, even though one of them is not running, it will still cause you trouble. So it's a bit annoying as far as I've seen for now. Okay, try my luck again here. Okay, that looks better. So yeah, so no conflicting port. Let's duplicate that session. So I'm having a second session on and just doing the usual post request to show that actually, or if it actually works. Let's see. We post something that has worked, and then we get something, and see if we get something back. Yes, and that is seemingly consistent. That sounds good. So if I were to, for example, restart that instance again, we should still be able to get the same responses. So if get should still produce the same output. So we're actually binding to the local MongoDB instance, right? So, right. So we didn't quite get to our goal to. Are you guys obligated to having another class or something like that?
Well,
No.
Huh?
I think there is another class starting here.
Oh, that's another. Oh, yeah, that's the constraint. Okay, yeah. Well, okay. Then we'll wrap that up tomorrow. First thing, next session, just linking those two containers. So. The idea is to create a MongoDB container and then link that container to the other one, how to achieve this. And this is pretty much what you need to know for your assignment as well. That said, we won't be strict on Dockerizing the MongoDB instance. It's probably just a recommended experience, I guess. You can still use the ones you have in MemLab already, right? The only thing that is part of the deliverable is have a Docker container for your main service. But as you have seen, it's no magic so far. Tomorrow we talk a bit about optimizing them because there are some issues there with Go images in this respect. But other than that, you kind of have the feature set you need to know about right now. Cool. We continue tomorrow. Thank you very much for attending. And thanks for your patience.